Okay, so last time we talked about factoring a third degree polynomial using two different methods, using our grouping as well as just dividing. So both those are really good methods that work for third degree polynomials. Dividing works all the time, so it's actually kind of a better method in that way. Today what we're going to talk about is what do you do when you're trying to factor a fourth degree polynomial. And spoil the surprise, we're going to do division. It's going to take a little bit longer. Luckily for you guys, there's not a whole lot we're going to make you do this. You need to see it and do it a few times so you know how to do it on your test. So factoring fourth degree polynomials is the first thing on the agenda. And the second thing is going to be what do you do when you're factoring by division with a leading coefficient. So first, let's look at our fourth degree. Okay, so again, this is we're just doing division. Is all we're going to do. It works exactly the same. I'm just going to walk through it so you can see the full process. So we look at our constant on the end, so this 6 here, and we're going to find all of the factors of 6. So if you list them out, we'll have 1, 2, 3, and 6, as well as any negative option of that. So I'm just going to say plus or minus 1, 2, 3, and 6. Okay. So the way that we do this is we choose one of those factors, and we use that factor to do synthetic division. And if we do that and we get a 0 remainder, then that's a factor. If we do it and we don't get a 0 remainder, then it's not a factor. So we're just going to run through that real quick, and I'm going to use ones that I know already work. Again, quick reminder, a good bit of these will work. So you have 8 options here, but you don't need to try all 8. You really just need to get one to work. So we'll start there, and I'm just going to use a regular 1. So we're going to try out 1 and set up the synthetic division. So we'll put it in the box, and our coefficients will be 1, negative 5, 5, 5, negative 6. I'm going to go ahead and put a box there where we'll look for our remainder. And a quick reminder just to be sure, because we put a 1 in the box, the factor that we're actually looking at here, the linear factor, is actually going to be x minus 1, not x plus 1, because you're always looking at the opposite. So now we'll do the synthetic division. So we'll drag this down and multiply, do a quick addition, multiply, add, multiply, add, multiply one more time, and add one more time. And we got a remainder of 0, which means that that factor works. So what this tells us is that x minus 1 is a factor, and because this is our result when we divide that out, this is a factor as well once we translate it back into solid math. So we have x minus 1, and now we have, if we work backwards, our remainder, numbers, x's, x squareds, x cubes. So this is a cubic factor, so x cubed minus 4x squared plus x plus 6. Okay, so now we got one step further. We found a factor, but we're not done, because now what we have to do is we're left with a cubic that we have to factor. So we'll do the exact same thing here, and we'll work with a 6 again. Now working with a 6, since we already did a 1 up here, I'm going to try doing like a negative 1, and we'll see if that works. Just using a little strategy you could use. You could go back to the exact same process if you wanted. I'm just going to try a different one. So we'll do negative 1, and then now we're going to use this for what we're dividing synthetically. So 1, negative 4, 1, 6, and a box for the remainder. And we'll work through it. Pull down the 1. 1 times negative 1 is negative 1. Add those up, you get a negative 5. Negative 5 times negative 1 is 5. 5 plus 1 is 6. Times negative 1 is negative 6. Add those together, you get 0. So that one worked as well. And real quick, let's backtrack. First, we had a negative 1, so the factor we're looking at is x plus 1. And so that guy worked. So now we'll keep our x minus 1 and carry it down. Now we'll tack on this new one we found, the x plus 1, and we'll add that last factor that we found there as well. And that's going to be an x squared minus 5x plus 6. Okay, so almost done here. We've narrowed this down from 4th degree to now a 3rd degree, and now we're to a 2nd degree. Now that's a nice easy one that you guys should know how to factor, so I'm not even going to walk through that. I'm just going to tell you what it is so you can check yourself. So we're going to keep these same two here, x minus 1, x plus 1, and now this guy's going to factor to x minus 2, x minus 3. And now we have our 4 linear factors, and we're fully factored. Okay, so that's a 4th degree. Really no different than a 3rd degree. It's just a little bit longer. So now we're going to look at is what do you do if you have a leading coefficient? Because it does work just a little bit differently. So this leading coefficient technique, just like the normal division technique, works for really any power that you wanted to do. You could do it for 2nd, 3rd, 4th, 5th, 6th, and so on degrees. It just might end up being a lot of work after a while. So really only one key difference here that I'll get to in a minute. It's going to seem like it makes things a lot harder, but it really doesn't, because we're dealing with about the same process. But I'll explain that in a second. So just like before, we're going to look at our constant to find some factors. Okay? So I'm going to list all the factors of that constant. Now this is going to be a little bit longer list because this time we're going to have a lot because it's 30. So we'll have 1, 2, 3, 5, 10, 15, and 30. And obviously we have the positive or negative options. Now here's the kicker, the way we adjust for the leading coefficient. So what we have to do is find all the factors of our leading coefficient. Now this one's an easy one because it's 2, so we know we have 1 and 2 and obviously the positive or negative options. Now, here's the deal. What we have to do is we have to be able to pair all of our factors of our constant with all the factors of our leading coefficient through division. And by that I mean we have to do 1 divided by 1, 1 divided by 2, then go to 2, 2 divided by 1, 2 divided by 2, then go to 3, 3 divided by 1, 3 divided by 2. So we're going to get a much longer list of factors. So this time, if we divide everything by 1, we get just the list we have. So I'm going to keep that one and make another list now of if we divide it by 2. So obviously we'll have 1 divided by 2. 2 divided by 2 is 1. We already have that, so I'm not going to add that one anymore. 3 divided by 2. 5 divided by 2. 10 divided by 2 is 5. We already have that. But then we'll have 15 divided by 2. And 30 divided by 2 is 15. We already have that. So now what we're looking at is, and once again we want the positive and negative options. So now we're looking at is a list that consists of all these green numbers and all these blue numbers. So that looks like it just made our job a whole lot harder, but it really doesn't, because we can still basically just work with this list because we just need one to work. It's not like we need to find all the ones that work, we just need one. So we'll start with this list on the easy ones and then just only use this second list if we have to. So to start, I'm going to try out 2 because I know that 2 works because I cheat. So we're going to use 2, and I'm going to plug in all of our factors here. So we have our coefficients, I should say, 2, negative 3, negative 17, and 30. Put a box for my remainder. And remember here we're not looking at x plus 2, we're looking at x minus 2 as a linear factor. And so now we're just going to run through it. So pull the 2 down, multiply, you get 4, add them together, you get 1, multiply, you get 2, add them together, you get negative 15, multiply, you get negative 30, add, you get 0. So that one works because we got a remainder of 0. So our first factor is going to be x minus 2. And then we know all of this stuff over here is going to be a quadratic factor. So that's now 2x squared plus x minus 15. And so now, just like before, you would have to factor this quadratic factor as well. Now, the only real difference here from what we've been doing is now we have a leading coefficient again, so we have to use the Berry method. But again, you guys have done that, you know how to do that, so I'm just going to give you the factors so you can check yourself if you like. So we'll carry down the x minus 2, and our two factors will be 2x minus 5 and x plus 3. Okay, so that's all. It's really not that much more difficult. Just gives you a little bit, a few more numbers to try and consider. I do anticipate some questions about this one for sure in class, so come ready with your questions and let me know if you need any help.